Okay, first time I did this, it did not record. So let's try again. In this video, we are going to talk through how to graph a sine function using transformations, but using the transformations to find certain characteristics and then applying the characteristics to create the graph. So first we have a sine of bx minus c plus d. We can get some information from this. The amplitude is the absolute value of A. Remember, the amplitude is that distance from the midline to the max and the midline to the min. And I'm sketching sine in this case because we're going to talk about sine first. The period is given by 2 pi over b, and remember the period is kind of how long it takes the distance for one cycle. So this distance right here is going to be 2 pi over b. That's going to be something we see a lot, is these 5 points. And we'll see that on the next page. The phase shift is like your horizontal shift, and it's found by setting what's in the function equal to 0 and solving for x. Okay, you can also think of it as c over b, but if you're going to think about it that way, you have to remember that c is negative in the kind of general form. Lastly, the vertical shift is that d value on the outside of the function, and what it tells us that's helpful is the midline. The midline is y equals d. So this right here is y equals d. Okay, you are going to have to memorize these things to be able to graph a sine function, so I'd recommend writing them down, pausing the video and doing that if you do not have them written down yet. Okay, the last kind of two components that we're going to talk about that are going to help us graph are the increments and the starting point. So the increments tells us kind of the gap between the critical points. So we've talked a little bit already, but we'll see it more next, about kind of the 5 starting points for sine. And to get from this first point to the last point is your period. But if we kind of think about the gap between all of the points, there's 4 gaps. And so the way they're equal, I'm going to figure out what they are, is the period divided by 4. So that's what we want to usually count up by. That's what we usually want to count up by on the x-axis. Sometimes, depending on what the phase shift is, we might have to meet in the middle or make some common denominators, but our increment is still going to be the period divided by 4. For sine, because the parent function sine of x starts at 0, 0, our new starting point after it's been transformed is going to be phase shift, comma, the midline. Okay? We're just going to jump right in to some examples after we talk about the parent function and how it looks. So when sine is positive, these are the 5 points that we are going to kind of manipulate, think about, move around, change. And then what's nice is the pattern just repeats itself. Okay. The start point normally starts, if there hasn't been any transformations, at 0, 0, because the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. So there's where our values come from. They come from the unit circle. Okay, those 5 points are what gets kind of moved around when we apply our transformations. Okay, you can see we start at our start point in the middle. Then we go to our max, we go high, then we go back to middle, then we go low, our minimum, and then we go back to middle. So some people like to use H and L because all of these start with M's, right? Middle, max, middle, min, middle can be a mouthful. That is when A is positive. Okay, I'm going to go ahead and in green and show you what happens when A is negative. When A is negative, our amplitude is still the same. So this distance right here is my amplitude, and this distance right here is my amplitude. When A is negative, it's a vertical reflection. Oops. It is I don't know what's happening. It is a vertical reflection. So instead of going to our max first, we're actually going to go to our min first. So it would be middle, min, middle, max, middle, min, right? So it will look very similar, but it will be reflected. So we take that into account when we're graphing it by flipping our starting 5 points. Okay. Let's do some examples. Okay. For this one, I'm going to start by picking out A, B, and C. But you don't really need to do that, but it can help you to find the pieces if you would like. So there's A, B, C, and D. All by themselves, they don't really tell us anything, but we can use them to find the pieces of our graph. So we've got our amplitude is going to be 3. Our period, it's going to be 2 pi divided by B. Now this we have to be able to do by hand because one, you probably won't have a calculator on a test on this, but also if I type it into my calculator, it's going to give me a decimal. So I need to remember keep, change, flip, and I'll get a period of 6 pi. My phase shift is going to be C over B, which is really easy to pick out if you have written it like that. Again, we'll keep, change, flip. But remember, you can also set the inside of the trig function equal to 0, multiply both sides by 3, and you'll get the same answer. Okay. My vertical shift is kind of down to -2. D is -2. And that's helpful because that gives me my midline of y equals -2. Okay. The last couple bits that we need our increment. And our increment is going to be our period divided by 4. We'll reduce that to 3 pi over 2. So that's what we're going to count up by. That's going to be kind of the distance between our points. And then my starting point is normally 0, 0. Okay, but it's been shifted horizontally and vertically. So it is going to be 3 pi, comma, -2. Okay, because sine normally starts in the middle at 0. Because this hasn't been reflected, these are the 5 points I'm working with. Now, honestly, I do this part in my head mostly before I put it on an actual graph, but it wouldn't be very helpful because you can't see what's going on inside my head. So that's why I'm sketching it out. So this might seem like I'm graphing it twice, but this is the process I can use in my head to graph the transformations easily. So for starters, I like to do the midline. I just think it's easier to think about the vertical transformations. So those are my 5 starting points for sine. My midline is going to be y equals -2. And then my amplitude is 3, which means this distance here is 3 and this distance here is 3. If I go 3 up from -2, it's going to be -1, 0, and 1. So the highest I'm going is y equals 1. This kind of height here is y equals 1. If I'm at -2 and I'm going down 3, the lowest I'm going to go is -5 because it'll go -3, -4, -5. Okay, so that's the vertical stuff. I've handled my vertical stretch and my vertical shift. Horizontally, I know my period, the distance between these 2 points, should be 6 pi. But I'm starting at 3 pi because of the phase shift. So 3 pi plus 6 pi, that means I should end at 9 pi. Okay. My increment is this distance, the distance between the points, and it's 3 pi over 2. I'm going to have to count up by 3 pi over 2, which means making a common denominator. So that's kind of thinking of 3 pi as 6 pi over 2. Right? 6 pi over 2 plus 3 pi over 2, this right here, will be 9 pi over 2. 9 pi over 2 plus 3 pi over 2, they already have a common denominator. That's 12 pi over 2, which is 6 pi. 12 pi over 2 plus 3 pi over 2 is 15 pi over 2. 15 pi over 2 plus 3 pi over 2 is 18 pi over 2, which simplifies to 9 pi. And that's great because that's where I was supposed to end anyway. Okay. Now I put that all on like a formal graph that's labeled. I'm going to move this up a little because I'm mainly negative. I need a height of, that's supposed to be positive 1 over there. The highest I'm going to go is positive 1. I need a highest height of 1 and lowest of 5. Okay, I'm going to count by pi, 3 pi over 2. I could count by pi over 2, but then my things would be closest together. If possible, you always want to count up by the increment. So let's zoom in here. Let's zoom in here. It doesn't really matter where you put these, right? It's kind of weird. These start to all look the same. Right, we know that every 2 jumps, this would then be 9 pi. This would be 12 pi. Negative 3 pi over 2, negative 3 pi, negative 6 pi, negative 9 pi. This is 1, 2, negative 4, negative 5, etc. After 6 pi, we would have 15 pi over 2. Okay. What's important is really making sure you're counting up on both sides of the axes equally. And then once you graph those 5 points, it's just a matter of continuing on, continuing with them. So my midline, let me pop that in, is going to be at negative 2. Okay. You don't have to put that in. It's not actually part of the graph. It's not like an asymptote where you kind of sketch it in and sketch the curve following it. It's just a guide to help you. So you certainly don't need to put it. We'll start at 3 pi negative 2. Then we will go to high, the max, 1 increment over. Then we'll go back to the middle, 1 increment over. Then we'll go to the min, 1 increment over, then we'll go back to the middle. And that's 1 period. Oftentimes you're asked to draw 2 periods or to the edge of your graph. So we'll do 2 periods. 1 increment over, I'm down. Next increment over, I'm middle. 1 increment over, I'm up. Next increment over, I'm middle. Okay, and that was a whole nother period of it. Okay. Let's connect my curve. If I went through that too fast, because it's the second time I've done it within 20 minutes, go ahead and rewind, pause, so that it's not too fast for you. And we're going to do one more sine one, this one being negative. And this one I am going to move even faster through. So again, maybe pause it, try it on your own, try and find the pieces, and slow it down as needed. All right, we need to find amplitude, period, phase shift, midline, increment and our starting point. Okay. The big thing I notice about this one is it has been reflected. So those 5 points that we're going to kind of move around, it's still going to start middle, but it's actually going to go down first, then middle, then high, then middle again. My amplitude will be 1/2 because it's the absolute value. My period will be 2 pi over 2, which is pi. My phase shift will be negative pi over 4 divided by 2, which is going to be negative pi over 4 times 1 over 2, which is negative pi over 8. My midline is going to be y equals 0. There was no vertical shift of any sort. My increment is going to be pi over 4. My starting point is going to be negative pi over 8, 0. Okay, because it was horizontally shifted but not vertically shifted. This is a situation where my increment and phase shift have different denominators, with my phase shift having a lower one. So I actually want to think of my increment as 2 pi over 8. I want them to have the same denominator because I'm going to end up having to count up by pi over 8 or a denominator of 8 because of how it was shifted. Okay. So let's fill in our sketch real quick. We know our midline is y equals 0. Our max is 1/2 and our min is negative 1/2 because this distance here is 1/2 and so is this distance. My period is pi, but I start at negative pi over 8. So negative pi over 8 plus pi, it's going to be negative pi over 8 plus 8 pi over 8 is 7 pi over 8. So this should end at 7 pi over 8, start at negative pi over 8. We're counting up by pi over 4, but that's kind of tricky to do because the denominator is different. So we actually want to think of it as counting up by 2 pi over 8. So this is going to be pi over 8. Pi over 8 plus 2 pi over 8 is 3 pi over 8. 3 pi over 8 plus 2 pi over 8 is 5 pi over 8. And then it works out 5 pi over 8 plus 2 pi over 8 is 7 pi over 8. And now we have everything we need. And what you will start to notice, because you are creating your own graphs, is they all start to look the same, right? If I were to graph this function on this one, it would be really, really shallow, right? It'd be really, the amplitude would be really small. But I ain't graphing it on there. And I don't want to graph it that small. It's hard to graph small. So I'm going to call that 1 and this -1, which would make this half and this -1/2. And so all of your graphs, they're going to kind of look the same. And that's okay, so long as you're labeling it. And I'm going to count up by pi over 8 so that I can effectively graph my phase shift. We just have to be careful that our increment is 2 pi over 8. So I'm just going to go ahead and label every 2 because that's where my points will actually be moving. Right, so let me explain that one more time. My phase shift is negative, is it negative? Yeah, is negative pi over 8. But my increment is pi over 4, which means the gap between my kind of critical points is pi over 4. But I need to think of that in terms of over 8 so that I could graph my phase shift correctly. So let's put that in. It's going to be at 0. And then I'm going to go an increment, which is a jump of 2, and I'm going to go down because it's been reflected. I'm going to go an increment, which is a jump of 2, and I'm going to go middle. I'm going to go an increment, which is a jump of 2. Right, this distance here is pi over 4, but we're thinking of it as 2 pi over 8. I'm going to go an increment here. And that is 1 period. And then I can go the opposite direction following that pattern. So an increment, remember that's 2 jumps because the increment is 2 pi over 8. Up, an increment, middle, an increment down, increment middle. I could go on forever and ever. And then I just connect my curve. So here was our first period, and this should match up kind of perfectly with this idea. And this idea came from these pieces of information, and you can jump from this straight to this. This is just me kind of doing that part in my head, but forcing myself to write it. And then we'll continue on here. And we'll continue here. If you wanted to continue, or if you were asked to continue kind of to the edge of the graph. And that's that. That's